All right, here we go. So today we're going to talk about the bisectors of a triangle. This unit is primarily based on triangles as a whole. Today we're going to talk about the different centers of a triangle because there are more than one, and it depends on the type of center you'd like to find. Today we're going to talk about the bisectors of a triangle. So as a quick warm-up, I have a picture here, and if we were in class, I would ask you to predict kind of where the center of the following triangles would be. If I gave you three triangles and I asked you to find the center, what would you say? Some might put a point here, and a point here. Not that that's necessarily incorrect. But as I said before, there are multiple centers to a triangle, and today we're going to learn what are they and how to find them. For example, one of the centers of a triangle could be here. One of them would be out here. There would be a center here and here, and about a center here, and all the way out here. So the interesting thing is the center of a triangle depends on the type of center that you're talking about. And we're going to talk about two of the different centers today. Now, in terms of centers of a triangle, it's going to come from this overall concept of these circles. For every triangle that exists, we have something called an inscribed circle. That is a circle that is placed inside of a triangle, and it touches the triangle on each side just one time. We also have a circumscribed circle. A circumscribed circle is a circle that touches just the vertices or the corners of a triangle. Every triangle has a circumscribed circle that can be made and an inscribed circle. The center of those circles are also counted as the center of the triangle. So for example, the center of the inscribed circle would be about here. So we could place that as a center of the triangle. The circumscribed center has a center of about right here, almost on the outside of the triangle. We'll talk about how that is and why that is in just a second. Let's talk about how to find the circumcenter of a triangle. First of all, the definition is it is the point of concurrency for perpendicular bisectors of a triangle. There's a lot of vocabulary words in that statement, so let's break that down, starting with perpendicular bisector. A perpendicular bisector does two things. It cuts a side in half, and it makes a right angle. So perpendicular is where we get the right angle. Bisector means to cut in half. So if I had a triangle, and I asked you to construct the perpendicular bisector for segment AC, what that would entail is finding the midpoint of AC. We want to bisect it. So let's say here's the center. If this is the midpoint or the center, we can say that this side is congruent to this side. And then perpendicular means it needs to make a 90-degree angle. So something along these lines. When creating any sort of perpendicular lines, make sure you show that they're perpendicular. We do that by putting in the right angle box. And that red line that I constructed would be considered a perpendicular bisector. It is both bisecting segment AC and it's perpendicular. So that is part of how we find a circumcenter. We also have the word concurrent lines up above. To review, concurrent lines are just three or more lines that intersect at a common point. So anytime you have three lines that cross at one point, we call them concurrent lines. So we would say that these three lines that I've constructed are concurrent because they all intersect, and the point at which they intersect would be called the point of concurrency. So this red point would be the point of concurrency. So taking all those vocabulary words and kind of piecing it back together, for the definition of a circumcenter, it is the point where all three perpendicular bisectors of a triangle meet together. So if you construct three perpendicular bisectors of a triangle, they will meet at a point, and we call that the point of concurrency, and it is the circumcenter. Now, I have gone through and I have made a circumcenter already graphed. This is a website called GeoGebra, and I have put it in your notes. And we're going to kind of mess around with this to answer the following questions. Before I read them, just to let you know what's going on, we have a triangle that I constructed, and I constructed the perpendicular bisectors of this triangle. So we have one right here. We can see the right angle mark, one here, and one here. The point at which they meet is called the circumcenter. You can drag around these points and see that as you drag things around, the circumcenter moves. And sometimes the circumcenter can go outside of the triangle. This is still considered a center of the triangle, and it is the circumcenter. So you can kind of mess around with it, and we're going to answer the following questions. If the triangle is acute, then where is the circumcenter located? So I'm going to make a quick acute triangle. We can use angle B as a reference. This is acute, and the circumcenter is located inside the triangle. Next, if the triangle is acute, where will the circumcenter be? Obtuse. I could make an obtuse triangle here. I have a measure of 121 degrees, and that circumcenter is definitely outside the triangle. Last but not least, it says, if it is a right triangle, where is the circumcenter located? We can try our best to get this exactly on the 90. If not, we'll get close. There it is, 90-degree angle. This is a right triangle, and the circumcenter is neither inside or outside because it is on the triangle. So we can kind of manipulate those sides to see where does the circumcenter end up. The circumcenter is dependent on the type of triangle that we have. Now let's talk about why is this important. We have our circumcenter theorem. It states that the circumcenter of a triangle is equidistant from the vertices of the triangle. As a reminder, equidistant means equally distant. So this point P, the circumcenter, is equally far away from vertices B, C, and A. It's an equal distance. Therefore, this says on number 5, name the 3 congruent segments according to this picture. That would be PA, PC, and PB. Those are the 3 segments that go from the vertice to the circumcenter. And the whole point of the circumcenter is that it's equally far away from every vertice. To find these questions 6 and 7, these are the 2 things that you need to know, the most important. How do you find it, and why is it important? Number 6 says to find the circumcenter, you must construct the perpendicular bisectors. So construct the perpendicular bisectors of each side, and you will find the circumcenter. The circumcenter is important because it is equidistant from the vertice. So it's equally far away from every corner. Now, we said before, this is the center of the circumscribed circle. So if this is constructed correctly, we should be able to form a circle that goes around this triangle and only touches each vertice once. If this is the circumcenter, we can verify this very quickly. On GeoGebra, we have some basic tools over here on the left. We're going to select the one that says circle with center. It wants you to select your circle. So I'm going to select the center. That's the center of the circle, sorry. And then you just draw out how far the radius should be. It should go to A, or any of the points, it doesn't matter. And you will see that you have a perfect circumscribed circle. This circle will touch every point once, and it doesn't matter where you move them around, that circumcenter will adapt. So again, that circumcenter, that point, this red point, is the center of the circumscribed circle. It is important because it is equally far away from every corner. So the distance from G to A is the same as G to B, and it's the same as G to C, because each of those distances would be called a radius of the circle. And every radius in a circle has to be the same length. So that's our circumscribed circle. With that, we can do an application. Those of you who have me in class, we will do this on paper with our protractor and with a ruler. I'm going to try my best to do this online, and maybe it'll be more of a concept thing. But here's kind of an example of how you can use this. This says you and your friends are each at 3 different locations. One is at HLGU, one is at McDonald's, and one is at the riverboat. You want to meet up at a spot that is equally far away from all of you. Where should everyone go? So what this is saying is there's 3 locations. So I'm going to go ahead and mark those. Mark them in red, because why not? All of these are locations on our map. We have HLG, we have McDonald's, and we have the riverboat, which is right over here. That's the location of you and your friends. Now, according to geometry, any 3 points can create a triangle. So let's triangulate our positions here. And we are curious. We all want to meet up an equally far away distance. Now, there's only 1 point on the whole world that is equally far away from these 3 locations, and that would be the circumcenter. So what this question is actually asking us to do is find the circumcenter. And we're going to do that as closely or as accurate as we can, which in class will be easier. I should have rulers and protractors for you, but here's kind of the way that we're going to go about doing this. We need to construct the perpendicular bisectors. So we need two things. We need it to be perpendicular, and we need to bisect. Bisect means cut in half. So the first thing I'm going to do is just kind of measure my sides so I can find where the bisector is. Where is the middle? So looking at this from McDonald's to Mark Twain, I'm getting about 7 inches and 1 tick mark. So if I cut that in half, I'm going to use a different color here. That would be half of 7 is 3.5. Then we go 3.5. And then half of 1 tick mark is half a tick mark. So right about, hold on here, right about here would be my middle. And again, you're going to do this with an actual ruler. It should be a simpler process than doing it with this online one. Oops. And now that we have the midpoint, we can get rid of our ruler and we can figure out the perpendicular part. To figure out our angle, we're not going to use a ruler, we're going to use a protractor. And for those of you who may not have used a protractor in a while, it's a pretty simple process. You're going to take your point, your midpoint here, and line your protractor right on it. Just like this. So we have the center of our protractor on the point. The rest of your protractor should line up with that segment. Once we have that, we want to trace from our midpoint through the 90-degree angle. Just like this. So we have 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80. Here's the 90. And just to be safe, we'll go through both directions, just because we don't know where this is going to end up. All right, so there is one perpendicular bisector. If you'd like to show it's perpendicular, we can add a quick 90-degree angle. And that perpendicular bisector is done. In order to find the circumcenter, though, we need all three. So let's get our ruler back out. And let's figure out the length of another side. Again, you want to be as accurate as possible. This looks to be almost exactly 2 inches. Close enough. So I'm going to take half of 2 inches, which will be 1 inch, and say here is the midpoint, which we're going to use for the bisector. So I've now bisected this segment into 2 parts. Now I need to construct the 90-degree angle. So I will take my protractor, line it up with the left side, putting that midpoint exactly in the middle. Line it up as nice as possible. And then we'll construct the perpendicular component from the midpoint 90 degrees. All right. And we have one more left. We need to do this long segment from HLG to the riverboat. I'll get my ruler out. And we're going to measure as accurately as we can. Okay, we have 7 plus 1, 2, 3, 4, 5, 6 tick marks. So half of 7 is 3.5. And I had how many tick marks? 1, 2, 3, 4, 5, 6 tick marks. So half of 6 tick marks is 3 more tick marks. So I'm going to look for 3.5, which is right here, 3.5, and then go up 3 tick marks. 1, 2, 3. And here's the midpoint. Now I have my third midpoint. I just need to get the perpendicular component. So let's make a 90-degree angle that goes through that midpoint, making it a perpendicular bisector. All right. Line tool. Both ways. And as you see, all 3 lines, all 3 perpendicular bisectors meet up at one point. This is the point of concurrency. And this will be my circumcenter. the point where all three perpendicular bisectors meet. Right here. So the answer is, if I have someone at HLG, McDonald's, and Mark Twain Riverboat, the one spot where they should go so that they are all equally far away from each other, or an equal distance, would be Riverview Park. Meaning, and you don't have to draw this in, the distance from here to here, from McDonald's to the same spot, and Mark Twain to the same spot, those will all be equal distance, equally far away. Everyone has the same travel distance to get to the same spot. Now, there will be an extra credit question today that I will give you whether you're in class or not in class, and we'll have you do the same thing, except using places from around campus, and I'll talk about that more when we get there. But for now, there's my answer, Riverview Park. So that is the circumcenter. That's how to find it. That is one of the two. The other type of center we have is called the incenter. It is the center that is equally far away from every side instead of every corner. In order to construct it, we need to construct not the perpendicular bisector, but the angle bisector. An angle bisector is exactly what it sounds like. It is the bisector that cuts each angle in half. The incenter, the second center we're talking about today, is where the angle bisectors meet. So this one says, construct the angle bisector for angle B. That would be a segment. Let me change the color here. That perfectly splits angle B in half. And we're not going to necessarily do this one with a protractor, but we're just going to show that I have split this angle into two congruent pieces. This is the angle bisector. To find the incenter, I'm going to construct all three of the angle bisectors, and they should all meet at a common point. We'll call it the point of concurrency. Down below, I have already done this in GeoGebra. You can see I have a triangle. Each of the angles have been bisected, and they show you that they're bisected, and they all meet together at a common point. This is point D in terms of this picture, and you can move things around, and you can see how that incenter moves around. You will notice the incenter never goes outside of the triangle, and it never lies on the triangle. It is always inside the triangle. So you can kind of mess around with that. If you construct the three angle bisectors, they will always meet at a common point. Now let's talk about why is this important. This is our incenter theorem. The incenter of a triangle is equidistant from the sides of the triangle. So if I have an incenter, which is the point of intersection of these angle bisectors, it is important because it is equally far away from every side. The segment from P to D is congruent to the segment P to E, which is congruent to the segment P to F. So let's talk about what we need to know. The incenter is found by constructing the angle bisector, or angle bisectors, plural. And it is important because it is equidistant or equally far away from the sides of the triangle. So if this is true, back to our calculator, if this point is truly equally far away from every side, I should be able to construct a circle with the center D that goes to any of the sides, and we will end up with a circle that touches each side once. The segment from a D to G would be called a radius from the center to the edge, and so would D to F and D to E. And you see, as you move this around, it will update that circle. That point is always equally far away from every side, no matter what type of triangle you make, no matter how big, no matter how small. We call this the incenter. It is the center of the inscribed circle, and it is equally far away from every side. That is it for the homework. You do need to know the names of the centers, so both circumcenter and incenter, and you need to know why they're important and how you find them. So a quick recap. The circumcenter, you do the perpendicular bisectors, meaning you cut the sides in half. It is important because this center is equally far away from every corner. The incenter, on the other hand, in order to find it, you bisect the angles. Why is it important? Because it is equally far away from every side. So two different types of centers. On your homework, you're not necessarily going to be constructing these, but we're going to talk about congruent triangles. So for this one, it says find each measure. You have the measure from T to P. You see you have two congruent triangles here because we have side, angle, side, a quick review from last time. If the left side is 7, the right side is 7 because it is a corresponding component of congruent triangles. So a lot of this homework is going to be just setting things equal to each other. Then we have some incenter and circumcenter vocabulary. You guys can work through those as well. And that is it.